I'll be introducing and giving some background to the thermal unfolding and aggregation analysis part of this webinar and the instrument used for much of the analysis. When dealing with a library of options, picking out just one option can leave you feeling a bit like the statue on the left, overwhelmed. In this webinar, myself and Aaron will talk about antibody libraries and how to use the Uncle from Unchained Labs in a workflow to screen a library down to just the best performing options. When thinking about the stability of a protein, we can summarize it as two different options, conformational and colloidal. Conformational stability, shown in the blue on the left, is the ability of a protein to stay folded in its native state. Thankfully, examining a protein's fluorescence is one way to gain insight into the conformational stability of that protein and is an easy way to examine thermally induced unfolding during a heat ramp. Colloidal stability, shown on the right in green, can be thought of as the aggregation behavior of a protein. Gathering size information from static and dynamic light scattering can inform the understanding of a protein's colloidal stability. Both of these behaviors combine to paint a fuller picture of a protein's stability. So that leads us to the Uncle and its ability to gather conformational and colloidal information to paint a fuller picture of protein stability. Uncle is an all-in-one multimodal biologic stability platform that combines 3 detection methods in 12 applications to help you understand the stability and aggregation behavior of your proteins. To test any of these applications, only 9 microliters of sample is needed, and up to 48 samples can be run at once. Those 3 detection methods are full spectrum fluorescence, static light scattering, or SLS, and dynamic light scattering, or DLS. Uncle can see the full spectrum for fluorescence to give you the option to look at protein intrinsic fluorescence and evaluate tyrosine and tryptophan fluorescence, or use any of an arsenal of fluorescent dyes. Simultaneous with that fluorescence experiment, you can use static light scattering to monitor how the same sample aggregates. Uncle uses SLS at 2 wavelengths so you can track small and large particles at the same time. Dynamic light scattering, or DLS, is Uncle's 3rd detection method, and it is a highly sensitive technique to give you details about your protein's size and size distribution. Besides gathering size data, DLS is also powerful for understanding what's in your sample and can be used to quality check proteins before you start an experiment or after an experiment to get orthogonal confirmation of SLS data on aggregation. Lastly, Uncle also combines temperature control with these 3 detection methods, so you can run samples at room temperature, elevated stable temperature, or across any of a variety of heat ramps and understand how your proteins unfold and change in response to stress. Here's a look at how our 3 detection methods enable Uncle's applications. By using all 3 detection methods in unique ways, Uncle can give insight into protein stability not available by using 1 or even 2 of these methods alone. For example, there's an application for melting temperature in the first row of the table. With full spectrum fluorescence, you can monitor the unfolding of proteins by looking at the intrinsic fluorescence from the aromatic residues in your protein, mainly tryptophan. When a thermal ramp is applied, the heat stress causes the protein to unfold and its fluorescence signal changes. From this type of experiment, you can get a melting temperature which marks that protein's transition from folded to unfolded. Simultaneous with that fluorescence measurement, you can use static light scattering to monitor how the same sample aggregates over that same thermal ramp and mark the temperature of aggregation onset as a protein's T-ag, as seen in the table's second row. Later, Aaron will show how Twist uses this TM and TAG application to help screen through many different antibody constructs and understand which ones are the most stable and should move forward with development. For the Uncle, dynamic light scattering also uncovers a protein's size and polydispersity, and DLS or SLS can look at nonspecific self-interactions with B22, T22, and KD. So in short, this table of applications shows all the way Uncle gives insight into a protein's stability and aggregation behavior. Now allow me to introduce one of the key features of the Uncle, which is the uni sample holder. The uni is composed of an array of 16 quartz cuvettes that are easily loaded with a pipette. The high-grade quartz gets us great optical sensitivity for fluorescence and light scattering data, and the frame is an anodized aluminum that provides efficient heat transfer. The 16 samples are loaded into the uni and then are sealed in a blue frame with a silicone seal, so you know that evaporation won't be a problem during a heat ramp. Over a heat ramp, Uncle will excite and read the full spectrum fluorescence of a protein sample at numerous temperatures. Each line in this graph is a fluorescence read of a protein excited with a 266 nanometer laser, starting with a read at 15 degrees C and going all the way to 95 degrees. You can see by following the curves from top to bottom how they shift to the right side of the graph, which are the longer wavelengths. This phenomenon is called a red shift and occurs because the protein is unfolding. Buried tryptophan residues have a shifting fluorescence emission as they move from being buried in hydrophobic pockets to being exposed to an aqueous environment. This protein shows a classic red shift pattern, but you never know how each proteins will behave until you've tried it. Some proteins shift to the left, called a blue shift, while others can decrease in fluorescence without a shift. With this way of collecting full spectrum fluorescence, you have all the data and don't need to worry about unexpected protein behaviors. For proteins without tryptophan, Uncle also has a 473 nanometer laser that can be used as cypro-orange dye to excite fluorescence and determine unfolding.